I'm Stephen Fogwill. I'm one of the head teachers of science in a local high school near Newcastle University, and we're here to talk about physics today, and my job is to help you get some more marks in your HSC. We'll call it maximising marks for the HSC Physics paper. Alright, so there's 5 areas that I'd like to talk to you about in maximising your marks. The first one is, it might be a bit obvious, but it says know all of the content, the key terms, and all of your practical activities. That's the first one. Now it might sound like it's a hard thing, but I'm going to show you some strategies to make that happen for you. The second one is to understand all of the formulas. There are about 40 formulas that you need to know, and you need to know what all of them mean and how the content relates to each one of those formulas. Once again, there's a special strategy that I use with my students that I'm going to hope you can adopt and use for yourself. The third one is to know what the questions expect you to write. Now, you've probably heard about verbs before. We'll talk a little bit about the verbs. It's very important in physics as well. So we'll go through with an example of what you have to do there with the verbs. Also, we'll look at the idea of dot points and the questions that can come from contexts as well as other parts of the syllabus, including the skills table, which is 9.1 in the syllabus. 2 other things. We want to have some strategies to help you with your exam time, because that's critical when you're finding marks. And the last one is what to do when you finish the paper. You certainly don't leave, how you're going to actually check your answers to get more marks than you would if you didn't check them well. Now let's look at that first one, which was to know all of the content, all of your pracs and all of the key terms. Firstly, to know all of the content, you actually have to do the course. You have to go to class, write your notes, do your pracs, etc. But once you've done that and you've done the work, the idea is to write summaries. And each time you write your summary, you go over your summary and make it briefer and briefer. This graphic here is one of my students who wrote summaries. This particular graphic here shows the whole content for the space unit. 1 page for the whole unit. Each part of that graphic here, like this little part in here, suggests that she did an experiment. And the experiment was to find the acceleration due to gravity using a pendulum. When she looks at that little tiny graphic there, she can remember what the experiment was, what the process was, making lots of 10 swings, doing averages, doing multiple lengths of the string, doing a graph, all the things for reliability and validity she can sit down and talk about because she's got that little graphic there to remind her about what she did. So the whole course, all of the pracs, all of the key terms, all the concepts for the space unit are on 1 page. Have a look at her next 2 pages for motors and generators. This particular page has got, once again, a lot of little diagrams showing structure of transformers and meters, the motor effect, induction motors, all of that's on 1 page. The second page goes into some more aspects of that particular topic, but 2 pages only for that one topic. So when she gets down to this situation, it's not a complete summary with all the words, but what it is little tiny keys to help her remember just what she's learnt. It takes time to develop these, but once you've got them, you can go through each unit in about 15 minutes. That means you can study the whole course in 1 hour. And if you do that over and over again, when you go into the examination, what can you do? You can remember all of your work, all of the pracs, and all of the key terms. And you can do it often and over again. So when you're in exam, you're snappy with your content. That makes it easier for you to score more marks. Okay, so what about knowing all of your formulas and how that relates to your content? What I get to do with my students is I get them to write out some formula cards. So for each formula, they write the formula in the middle of the card, and then they write around that some of the stuff that they need to know for the content of the course. Now, in amongst all that, they have to write down what the units are and what how those particular things come together. If there's an angle, for example, they have to have a definition for that angle on there. And we'll show some examples of that as we go. But if you have a look at the graphic here, you can see that there's quite a few there that we're showing. Here's some more. This one here, this formula that's F equals QVB sine theta is actually my favourite formula. It's because the formula itself is a sentence. It says there's a force acting on a charged particle moving in a magnetic field. So if you read F equals QVB sine theta as a sentence, then you know what that is. If you do your formula cards and you can go over them quickly, you will know all of your formulas. When you get into the exam, you don't have to think about the formulas, therefore you get more time, you can be snappy with the things that you have to answer, you don't get tricked by questions that have got unfamiliar information in it, what you don't have to use. And of course, if you've got more time, you can get more marks. That's what this is about, maximising your marks. Okay, so let's talk a little bit about the structure of the paper. The paper is given to you as a whole bundle. It's lots of pages. At the very front, there's a Part A. Part A's got 20 multiple choice questions. It runs for 35 minutes approximately. It's not 1.5 minutes per question. The questions range in difficulty, so you need to space out your working there. Some of them you're going to be able to do in 20 seconds. Other ones will take you 4 or 5 minutes, and you'll have to get the calculator out to work the answers out. After that, there's about 55 marks. In fact, there is exactly 55 marks of questions to do where you have to write answers to those. We call them extended response questions. And at the end of that, there's another part, section 2, that's got the options in it. You do one option. You should know which option you're doing. You do just the one. And in fact, there's a nice little strategy that I'll ask you to do when you're preparing for the exam, when you actually walk into the exam, that asks you to just read that one option during your reading time. Let me tell you what I mean by some of the multiple choice questions are a little bit harder or a bit tricky. This particular question here was asking students to look at the graph output from a data logger, from a primary and a secondary coil. Most students that I show this question to have no trouble at recognising the questions about a transformer. Not only that, they can tell from the coils and the power source that it's a step-up transformer. Not a problem at all, but the question said, what's the graphical output going to be? Most students got it wrong because they didn't look at the switch and the power source next to it. All right, when we get to the written questions, it's really important for you to know what to look for in the answer so that you can, or in the question so that you know what to write. Most of the questions that relate to, for example, one of the verbs called explain, are really expecting you to write a cause and effect answer. If we look at some of the dot points in the physics syllabus, they sort of lend themselves more to a straight question. This one here, which says explain how induction is used in cooktops in electric ranges, is a really good one that lends itself really well to a cause and effect question. If we look at the answer to that, it's really important to make sure that you've got cause and effect in there, and not the sort of answer that your mum could give because she's got an induction cooktop at home. You know, say, yeah, I've got it and I turn it on and it cooks the food. We need to see the physics in there. So in this case, I'm going to read this one out to you. It says, AC in the cooktop coil produces an oscillating magnetic field. So you see the word produces as a cause and effect word, all right? That induces oscillating eddy currents in the metal base of the pan. So once again, we've got this does this, so it's a cause and effect. The metal's resistance to these eddy currents causes the base of the pan to heat up. You might see here that I've even put in an equation. It's physics. Let's show the examiners that you know some physics. Put in the equation. This heat is transferred to the food and causes it to cook. It's a cooktop, so you should say something about cooking the food. When you do an answer like this too in physics, it's really good to draw a diagram. Even if the diagram's small and dodgy, it can really help the examiners know that you know what you're on about. Here's one that I drew for this particular question. You might be able to recognise the broccoli at the bottom, as somebody called it. It's actually a coil. It's labelled the induction coil, and the little crosses are identifying a magnetic field at a particular instant. So something like that, the examiners will see that and go, this is brilliant. This person really knows what they're talking about. They've given us a cause and effect few sentences, and they've given us a nice diagram to tell us what they think they're talking about.